Have you ever wondered if there's a moment in life when the universe decides to throw a question so massive at us that everything has to stop and look up at the sky? Today, I want to tell you a story exactly like that, one so weird that has left even the smartest people in science scratching their heads. What if I told you there's an object from outside the solar system that traveled billions of years through the dark between stars, and on October 29th, 2025, right at perihelion, it suddenly lit up like someone flipped a switch inside it. Not just a little brighter, not a normal comet getting bright. Its brightness doubled in an insanely short amount of time, a jump in magnitude no model predicted. And the wilder part, its spectrum shifted blue, bluer than sunlight itself. When you see that blue, you're looking at strongly excited carbon molecules like C₂ and NH₂, the kind that only show up when something way more energetic than usual is happening. But that's just the surface. Within 30 days, the water outflow from C₃/ATL has jumped nearly 40 times. Imagine something that slept in darkness for billions of years suddenly starts spewing water into space like a fire hose turned on full blast just because it got close to our sun. And if that wasn't strange enough, images from SOHO, Stereo, and GOES-19 show C₃/ATL is stretched out like a thin streak of light with zero dust tail. Normal comets always have dust, that's why we see those gorgeous tails millions of miles long. But C₃/ATL has none, just gas, pure gas, as if someone deliberately removed every dust particle from the process. And I know you might be thinking, Elon, you're not an astronomer. You're right, I'm not. I'm the guy who spends most of his time building rockets, optimizing spacecraft physics, and putting humans in orbit. But that's exactly why I look at data like an engineer. And this thing, C₃/ATL, isn't just interesting, it's profoundly weird. It's the kind of data that makes any engineer stop and ask why. Because nature always has its random chaos. But what we're seeing here is sudden brightening exactly at perihelion, mismatched blue spectrum, no dust, and activity that looks scheduled, isn't chaos. It's rhythmic. It's precise. The kind of precision you don't expect from an ancient mindless chunk of ice. And here's where the mystery really opens up. Why did it brighten so dramatically? Why the blue spectrum? Why no dust? And most importantly, why did everything happen exactly at perihelion, as if it was designed to react at that precise moment? Right after C₃/ATL pulled off that unbelievable flare-up, things started getting weird in ways that made even seasoned scientists lean back in their chairs and say, wait, this doesn't fit any model. The first thing that grabbed everyone was the speed of the brightening. It didn't just increase, it nearly doubled in an insanely short window, so short that technicians on duty double-checked the sensors thinking the filters had glitched. But after cross-checking data from multiple instruments and telescopes, they all said the same thing. C₃/ATL really did switch on like a light. Then when they analyzed the spectrum, it got even crazier. The light turned blue, a hard blue shift almost no one thought could be an analysis error. Normal comets don't do that. The sun isn't even that blue. But C₃/ATL glowed cold, clear, and blue, like some mysterious energy source was running inside it. When the spectroscopy team pulled apart the emission lines, they found C₃ and NH₃, stuff that shows up when carbon-rich material and ice get blasted off the surface. But the amount of material coming off was beyond imagination. Just in the 2 weeks before perihelion, the water C₃/ATL was releasing shot up 40 times compared to the previous 30 days, 40 times. If you've ever looked at rocket or jet engine graphs, you know this kind of curve isn't normal. It's like someone grabbed a pen and yanked the line straight up. And I say this as someone who's stared at way too many Falcon, Dragon, and Starship flight profiles. I've seen weird curves, but this is something else. It's way past, oh, that's interesting. This is okay. That's deeply weird. But the strangest part is the simplest no dust. When a comet heats up, it makes dust. Dust is what gives us those beautiful tails. C₃/ATL made none. Zero SOHO images showed us a long, thin streak of light with no dust tail behind it. Stereo confirmed the same thing. An elongated streak, slightly distorted but unnaturally clean. GOES-19, with its new coronagraph, showed pure gas outflow, no solid particles, no dust, no debris trailing behind. That's huge. Because if a comet is vaporizing that much water, it has to produce dust. That's been documented in hundreds of comets. Yet C₃/ATL acts like it's running on a completely different mechanism, like there's no solid material inside to make dust, or the dust is somehow being held back. Both possibilities give scientists a headache, and its shape makes everything weirder. It didn't form a coma, the fuzzy spherical envelope normal comets have around the nucleus. It didn't form a tail. It was just an elongated glow, looking more like a streak of energy than a reflective object. Some researchers described it as a stretched thread of light. Others said more like a plasma stream than a comet. And when scientists start using plasma-like for a comet, you know something big is going on. The weird factors line up: anomalous brightening, blue spectrum, massive water release, zero dust, elongated shape, all together creating a phenomenon no comet model can explain. And if you spend enough time watching the universe, you learn one thing: nature is often strange. But the strangeness of 3I/ATLAS goes beyond science's comfort zone. When research teams moved from observing the bizarre behavior to probing the internal structure of 3I/ATLAS, things got even more fascinating. If the brightening left them puzzled, this part made them question basic assumptions about interstellar objects. Data from James Webb shows the surface of 3I/ATLAS has been cooked by cosmic radiation for billions of years, creating a crust 50 to 65 feet thick, nothing like the thin crusts on solar system comets. It's thick, dense, and completely different. High-energy cosmic rays in interstellar space constantly hammered its surface, breaking molecular bonds, recombining carbon compounds, turning CO into CO4, and making the outer layer aged, hardened, and chemically far more complex than the original material. Basically, it's a natural armor formed over billions of years of radiation punishment, and only deeper than about 60 feet is the pristine material preserved from when it formed somewhere outside our solar system. If you ask my SpaceX engineers, they'd probably say, "How looks like a natural ablative shield." You know, ablative shields, the heat protection on Dragon or Thor ship that burns and flakes off to protect what's underneath. 3I/ATLAS has something similar, but built by the universe itself, not engineers. And the cool thing is, this armor doesn't tell us where 3I/ATLAS came from. It tells us what it's been through. That's the problem with interstellar objects. After billions of years traveling through radiation, almost nothing of the original structure remains except the altered crusts. What we see today isn't the original. It's the logbook of the journey. A friendlier way to put it: when you look at an interstellar object, you're not really seeing where it was born. You're seeing what the universe did to it over time, spans we can barely comprehend. That leads to one of the most intriguing hypotheses. Scientists are considering Suzanne Falsner's idea that objects like 3I/ATLAS could be planetary seeds, huge free-floating masses in the galaxy that can get captured by young star systems and become the starting cores for planets. Sounds like science fiction, I know. A lot of things were science fiction before they became technology, and I've watched that happen over and over in my career. If a young star system snags something like 3I/ATLAS, already big and massive enough, it could act as a gravitational nucleus, pulling surrounding material in and slowly growing into a planet. That would solve one of planetary science's big questions: how do tiny initial bodies clump into larger ones in a chaotic environment? Falsner thinks the galaxy works like a giant conveyor belt, where each star system picks up wandering objects and turns them into the next generation of planets. And if she's right, when we look at 3I/ATLAS, we might be looking at something that was supposed to become a planet, but never got the chance. Maybe it escaped its home system. Maybe that system no longer exists. Maybe it never got close enough to a dusty disk to become a world. Whatever the reason, it's here now, passing through our solar system after a journey so long it's hard to put into words. And the most important thing I want you to feel: we're not just watching some old rock. We're looking at one of the most ancient things humanity has ever touched with science, an object that may have formed before our sun ever lit up. Just thinking about that is enough to make anyone, even someone who spends his life building rockets like me, stop and admit the universe is vast in ways we still don't fully understand. When research teams turn to analyzing the orbit of 3I/ATLAS, they quickly realize the weirdness of this object isn't just in its light or radiation-altered crust. It goes deep into its very path. Normal comets coming into the solar system get noticeably bent by gravity. They never travel in a clean or perfectly straight line because the sun's pull, the planets, and even escaping gas jets cause small deviations. But 3I/ATLAS is different. When the data was run through simulations, its orbit came out almost perfectly flat, like a straight line cutting through our system, no wobble, no twist, no sign of strong interaction with any gravitational source. Some researchers described its path with words like unusually straight or uncannily perfect. And this straightness isn't instrument error. It's been confirmed by multiple independent observatories. And when they ask, why does an interstellar object that's traveled so long have such a clean orbit, nobody has an answer. That trajectory forced them to question the age of 3I/ATLAS itself. When they applied cosmic ray exposure models to calculate the depth of the altered crust, they arrived at a number between 7 and 12 billion years. What does that mean? It means 3I/ATLAS may have existed before the sun even formed, before the solar system had any planets at all. It isn't just older than Earth or older than our local comets. It's older than the star that sustains life here. We're talking about an object whose origins reach deep into galactic history, from a time when the Milky Way looked very different from today. Yet here's the paradox. Despite being that ancient, it's still almost perfectly intact. That 50-65-foot thick crust, the result of billions of years of cosmic rays hammering it, acts like natural armor that protected the inner core from total destruction. So this thing has retained its shape, structure, and stability to a degree that leaves scientists stunned. I remember looking at the data and saying, if this is natural, it's the toughest natural object I've ever seen. And that's not hyperbole. I've looked at everything from iron meteorite cores to solid carbon chunks to insane lab-grown materials, but very few things could survive billions of years cruising interstellar space without shattering. That leads to a more technical observation. The crust of 3I/ATLS isn't just thick, it's stable in a way that makes it look engineered for survival rather than a random product of nature. And honestly, if you handed these characteristics to a SpaceX engineer, they'd say it resembles an ultra-ancient ablative shield, a layer of armor forged by the universe itself over billions of years. That doesn't mean it's technology, but it does make people think. And I've said half-jokingly, if this is engineering, then we're looking at technology that's light years ahead of anything humans have ever built. Because if you wanted to build something that could survive billions of years between stars, you'd need exactly what 3I/ATLS is showing: thick shell, rugged structure, undisturbed orbit, and the ability to stay stable no matter how much time passes. Still, I'm not drawing conclusions. I'm not saying it's artificial, but when you line up all the data, insane age, ridiculous durability, unnaturally straight orbit, and non-cometary behavior, you understand why the scientific community is feeling uneasy. Anytime something in space looks too neat, too clean, or too stable, you can't help but wonder, is this just nature, or is there something else we're not ready to understand? And as many researchers have admitted, that question still has no answer. But perhaps what people argue about most regarding 3I/ATLS is the way it flared up exactly at perihelion, the very moment it got closest to the sun. If you look at its activity graph, you see what science calls threshold triggering behavior, like a switch that only flips when a precise condition, temperature, or radiation level is reached. Normal comets brighten gradually as they approach the sun. 3I/ATLS waited for the exact perihelion instant and then activated abruptly, as if reacting to a hard threshold. When you combine that phenomenon with the abnormal thick crusts, the overly clean orbit, the no-dust behavior, and the time-defying age, you understand why many people start asking the question nobody likes to say out loud. That brings me to a more engineering-flavored comment. If I had to design a self-operating probe that could survive billions of years in space, unprotected from radiation, no collisions breaking it, zero maintenance, what would I do? I'd make it look like a comet. I'd let nature itself be its shield. Nature does that better than any engineer ever could. A radiation-hardened shell dozens of feet thick. Perfect. No power required, no repairs, forged by the universe over eons. A structure dense enough to hold its shape for billions of years. Also perfect. No collision mitigation systems needed. No complex operations. The universe takes care of that part. Even its super clean orbit is something engineers like me can't help but notice. If you want to send something as far and as long as possible with maximum stability, you choose the least perturbed path possible. Nature only produces that in extremely rare cases. Intentional design, however, can. And here I have to be very clear. I'm not saying 3I/ATLS is technology or extraterrestrial. Really, I'm not jumping to that conclusion. But I'm also not ruling anything out, because science doesn't work by closing doors on questions. I once said in a discussion, I'm not saying it's aliens. I'm just saying if you wanted to hide something in the universe, you'd make it look like a comet. A comet is the perfect disguise, natural, familiar, able to exist for billions of years without drawing attention. And with just a few internal tweaks, different internal structure, you could send it across the galaxy and nobody would suspect a thing. I repeat, I'm not claiming any hypothesis. I'm only saying the data is making scientists uncomfortable because it forces them to consider things outside traditional models. And honestly, that's what science is supposed to do. Science isn't afraid of questions. Science is only afraid of not being allowed to ask them. When something in space behaves too perfectly, too cleanly, too precisely, like brightening exactly at perihelion without missing a second, like an orbit, so straight simulations don't need correction, like a crust so tough it survived tens of billions of years. Asking questions isn't wild speculation, it's responsibility. Some researchers have even suggested 3I/ATLAs could be a form of ancient technology, not from currently intelligent beings, but from a civilization that vanished before Earth even formed. I'm not saying I believe that, but I understand why they raised the hypothesis. Because we're looking at something that not only defies time, but defies the norms of nature as we understand them. Features like the dozens of feet thick crusts, clean orbit, bizarre radiation resistance, and perfectly timed activation, they all raise more questions than answers. And from the perspective of someone who spent his life designing systems that operate in extreme conditions, I have to say anything that perfect deserves scrutiny. It could be nature, it could be ancient tech, or it could be something we haven't defined yet. But if you stare long enough at 3I/ATLAs and deep enough into the data, you'll see what I see. This isn't an object you can just shrug off. Of course, when data this strange shows up, debate is inevitable. And one of the loudest voices right now is Avi Loeb, the guy who shook things up by suggesting Miyamoto might have non-natural origins. Now he's demanding NASA release every scrap of data on 3I/ATLAs, from spectra to images to tracking telemetry. And honestly, I think that's completely reasonable. Science has to be transparent. When data is held back or dribbled out, people ask questions, and they should. Not because anyone distrusts NASA, but because we're dealing with a once-in-many-generations interstellar visitor. NASA has a duty to share what they see so the entire scientific community can dig in together. The problem is the delay. Some stereo datasets still aren't fully public. Certain high-resolution SOHO images haven't been widely released. And what's really making people antsy is the observations from Curiosity and Perseverance, 2 Mars rovers with unique viewing angles. NASA has only said the data is being processed. That answer makes more than a few people raise an eyebrow. I don't believe there's a conspiracy here. Seriously, NASA isn't the kind of organization that wants to hide alien secrets. But I get why the community starts getting suspicious when information trickles out slowly. Because we've already been shocked so many times by 3I/ATLA. When something this weird shows up, people want to see every pixel as fast as possible. That uncertainty only adds to the mystery. There are unclassified data segments, unprocessed frames, unexplained measurements. Some independent researchers even claim NASA is struggling to analyze it because the patterns don't fit normal models. That could be true, or it could just be technical review backlog. Whatever the reason, the delay unintentionally fuels the feeling that something is being hidden. And the funny thing is sometimes all it takes is a few missing details for human imagination to outrun any spacecraft I've ever built. But that's exactly why I always say, be transparent, put it all out there. Science advances when everyone can see the data, poke at it, doubt it, and sometimes tear each other's theories apart to get to the truth. Truth isn't afraid of questions. Truth is only afraid of silence. Loeb gets that, and in its own way, NASA gets that too. Big systems just move slowly. That slowness is fine in ordinary cases, but with an unprecedented interstellar object doing unprecedented things, even small delays make the whole world nervous. I'm not endorsing conspiracy theories, but I won't deny that slow information flow makes people more vulnerable to inaccurate ideas. And honestly, I think the best way to kill suspicion is to open everything up. Because once the full data is out, the story becomes clearer and science can move forward instead of arguing in the dark. That's also why the pace of this story needs to slow down a bit right now. We've gone through the shocking data, the bizarre behavior, the baffling structure, and the possible artificiality debate that has everyone talking. Now it's time to zoom out and get ready for the bigger question. What does this actually mean for us, for science, and for humanity's place in the universe? When you step back from the arguments, the technical questions, and the confusing data, I think the most important thing 3I/ATLS gives us is a reminder of where humans stand in the cosmos. I've always said the universe doesn't care about our comfort zone. It doesn't care whether we feel ready to understand something or not. It just throws puzzles, anomalies, and moments at us that force science to stop and ask, what have we been missing? And if an object older than the sun, an object that has traveled billions of years through regions of the galaxy we haven't even named, suddenly drifts into our system, that's not a threat. That's a rare gift. An opportunity very few civilizations, if any exist out there, ever get. 3I/ATLS could be completely natural. It could be just one example of countless interstellar objects we'll discover in the future. But it could also be proof that we understand far less about how the universe works on the largest scales than we think. We're used to viewing everything through familiar models, but every time we find something that breaks those models, we tend to call it an error or an exception. Yet sometimes the exception is the most important thing of all. It forces us to expand our framework. It forces us to consider possibilities we once thought unnecessary. I've always believed humanity will become a multiplanetary species, not to escape Earth, but to secure our future, to push boundaries, to step outside the box we drew for ourselves. And objects like 3I/ATLS are exactly why we have to do that. They remind us the universe is bigger than anything the human mind has ever imagined, that there are things out there older than the entire history of Earth, that there are processes happening way beyond our current understanding. When you stand in front of something older than the sun, you can't help but feel a little humble. An object that has watched stars be born and die, drifted through giant radiation zones, survived events we don't even have words for. We don't know where it came from. We don't know what it's been through. We don't know which star systems it's seen, which supernova it's passed, or which dusty corners of the galaxy it drifted by. But right now it's here closer to Earth than it's been in billions of years. And that forces me to ask, are we going to make the most of this chance? I don't care whether it's natural or artificial. What matters is that it's telling us the universe is bigger, older, and way more complex than we realize. 3I/ATLS doesn't belong just to astronomy. It belongs to the bigger question humanity has always chased: who are we in the cosmic story? Where do we stand in the tens of billions of years history of the galaxy? And is it possible that technologies or structures beyond our wildest imagination once existed or still exist out there somewhere? I'm not saying 3I/ATLAs is proof of something extraordinary, but I'm not ruling it out either, because if the universe is big enough to produce things like this, it's big enough to hold stories we haven't even dreamed of yet. And sometimes the important part isn't the answer. It's that we dare to ask the question. Curiosity, the willingness to face what we don't understand, is what pushes humanity forward. And in this rare moment, with an ancient object passing through our system, I think the right thing to do is pause for a second, look up at the sky, and remind ourselves we're just starting to understand the universe, and 3I/ATLAs is the perfect reminder of that. So when you look back at the whole story, from the sudden flare-up at Perihelion, the spectrum bluer than the sun, the water outflow jumping 40-fold, the elongated shape with zero dust, the dozens of feet thick radiation rework crusts, the orbit so straight it confuses dynamical models, plus an age that predates the solar system itself, all of it adds up to one very simple message. We don't know what 3I/ATLAs is, but we do know one thing for sure. It's not normal. It doesn't look like anything we're used to seeing. It doesn't act like a comet. It doesn't follow models that have worked perfectly for decades. And that's exactly what makes it so fascinating. This isn't the time to jump to grand conclusions. This is the time to watch closer, to listen, to be ready to learn something new. In the coming weeks, the final data will come in the complete stereo datasets, the finished high-resolution frames, additional JWST spectra, and analyses from independent teams all over the world. And when it's all on the table, I believe we'll have answers. Those answers might be simpler than we think. They might be way more complicated. They might change how we understand interstellar objects, or they might even change how we understand the universe. But one thing is certain, we're about to find out. And for me, what matters even more is the attitude we bring to that moment. Stay curious. Explore, ask questions, be ready to face things outside our comfort zone, and never treat uncertainty like something scary. Treat it like an invitation to go further. The future isn't something that happens to us. It's something we build with our ability to ask questions and our courage to look at what we don't yet understand. 3I/ATLs, in its own very special way, is giving us that chance. And if the universe is trying to tell us something, I think it's time we listened. If you want to hear more weird stories from the cosmos, hit subscribe. We've got a lot more to explore together. See you in the next video. And who knows, maybe by then we'll have the answer to 3I/ATLs.